Hi guys, this lesson is still involved with law of signs, but now we're going to kind of take it a little bit further to something we call the ambiguous case. So if you recall from the video from last Friday and over the weekend, okay, I had said that we use the law of signs, hold on, wait for it, when we have two angles and a side, okay, so the ASA case or the AAA case. Okay, what we're going to look at today is going to be a little bit different. We're going to build on that. So before I introduce that, we're going to talk through these three little questions. So it says in triangle ABC, the measure of angle A is 48 degrees. Determine which of the following measurements could represent angle B. So if you think about how many degrees are in a triangle, I want you to take a second, pause the video, and think about which of these choices would work for angle B. Okay, hopefully you got A and B. Okay, 132 degrees would not work because 48 and 132 would be 180 degrees, and then there's nothing left for your third angle, and this would be over 180 degrees. Okay, find the reference angle for the given scenarios. So I tell you sine theta equals 24.8 over 25, and then same thing here, sine theta equals these two values. I want you to take a minute and pause, grab your calculator, and see what you think. Okay, make sure your calculator is in degree mode. Okay. Hopefully, when you did sine inverse of this, you got that theta is 82.7 degrees. If you did, fabulous. Hopefully, when you did this one, you got an error. And we'll talk about more of that as we go through here. Okay. Now, from part two, we want to use the scenario that worked. Okay, so it says one of the scenarios gave a value for theta while the other gave an error. Using the valid scenario, so A, determine all possible values of theta. Well, a lot of times kids say, well, we did 82.7 degrees. But be careful. Sine comes out to a positive ratio in which two quadrants? Quadrants 1 and 2. So this is the quadrant 1 answer. We need the quadrant 2 answer. So if we think about that, to get to quadrant 2 in degrees, we would take, this is our reference angle technically, so we would take 180 and subtract our reference angle, and we should get 97.3 degrees. That's our quadrant 2 answer. So keep that in mind also as we're going through some of this. Okay. So, law of signs, ambiguous case. So we use this when we are given two sides. So no longer, let's highlight that here, two sides, no longer just one side, and one angle opposite one of the given sides. So if you think back to your geometry, this would kind of be your ASS case. Okay, so if you think about this, we're given two sides. So let's call this like side 1, side 2. Okay, or you could have done side 1, side 2. And one angle opposite one of those. So it could have been this angle or this angle. I'll just pick this one. So notice you have the ASS case. Okay? So there are three conditions of what could happen in a scenario like this. You could get out a result where you have 0 triangles could be formed. And the reason that could happen is you want to think back to geometry. Okay? If you think about the side lengths that are possible, in geometry, you said if you had two side lengths, you would take their sum and their difference, and the third side length had to be between those lengths. So for example, if I had, I don't know, side lengths of 2 and 3, the third side length had to be between 1 and 5. Okay, so there are cases where you could potentially not be able to form a triangle, and we'll see what happens. Okay, we could get one triangle, or we could get two triangles. And I'll elaborate on all of this in the examples to follow. Okay? So it says solve each triangle. So notice that we have two side lengths and an angle. And notice that this angle is across from this side length. So we have one matching pair. So that's good. So to do this, we want to start with, we found out in our last one that sine of A over side A equals sine of B over side B, and sine of C equals divided by C. Okay, those three are all equal. So if we have one matching set, we can say sine of 72.6 over 13.7 equals, well, we have side B, oops, so we can find angle B. So what we're going to do here is we're going to cross multiply. Okay? So if I take 23.2 times sine of 72.6, and then that equals sine of B times 13.7. Okay? So if you figure out this value and divide by 13.7, you're going to get that sine of B equals 1.6. So from there, to solve for angle B, we would do sine inverse of both sides. Take a minute and try that in your calculator. Hopefully, you got no solution or an error. Now, why did that happen? Well, think back, okay? Think back to when we talked about the values that we could get out for sine. Okay, sine is opposite over hypotenuse, where the hypotenuse is always bigger. So you're taking a smaller number divided by a bigger number. That's always going to be less than 1 or negative 1. Okay, so sine is between -1 and 1 always. The outputs of sine of an angle is always between -1 and 1. So right away, when you see that this is smaller than -1 or greater than 1, it's going to be no solution and 0 triangles can be formed. It's not possible to create a triangle given these two side lengths and that angle. Okay, let's look at another example here. So once again, we have two side lengths and one angle. You always want to check that you're given two side lengths and one angle and that one of them goes together as a pair. So sine of 57.3 divided by 30.7 equals sine of B over 32.5. So let's cross multiply again. So when we do that, whoops. And then once you figure out whatever value this is, divide it by 30.7. So we get sine of B equals 0.89. So right away we're good because it's smaller than 1. Okay, if you do sine inverse of both sides, I got that angle B was 63 degrees. Well, I don't remember if I rounded that or not, but 63 degrees. Now, let's think about this. So before we had said that sine technically is positive in quadrants 1 or 2. So this would be the quadrant 1 answer. So what would our quadrant 2 answer be? So if we take 180 and subtract 63, we get 117. Now, we need to ask ourselves, with the information that we are given, okay, if we had, I'm just drawing a rando triangle here, not to scale at all. If this angle is 57.3 degrees and this guy is 63 degrees, could we find that third angle? Do we have enough degrees to find that third angle? Yes. So let's come over here then. So this is one of my triangles here. So if angle B is 63 degrees, okay, we could subtract 57.3 and 63 and find that angle C is 59.7 degrees. We definitely have enough room for a third angle there. Then we could also solve and continue and find side C. Now, you are not guaranteed that this is a right angle, or a right triangle, excuse me. So don't use Pythagorean theorem. Actually, we know it's not clearly by the angle marking. Don't use Pythagorean theorem. So let's use law of sines to find side C. So sine of 57.3 over 30.7, I'm going to go with the two that I know are given that are absolutely correct, equals sine of 59.7 over side C. So like our lesson from the other day, you could cross multiply and solve and find that C is 31.5. Maybe pause yourself and check when you actually cross multiply and solve that you get that. So that would be the three missing pieces from that first triangle. Now let's see what happens with this 117 degrees. Once again, not to scale at all. If this is 57.3 degrees and this is 117 degrees, do we have room for a third angle? Let's take 180, subtract those two, and yes, indeed, I have 5.7 degrees left here. So this is actually going to form two triangles. Okay, so here, angle B is 117 degrees and angle C is 5.7 degrees. We could then set up another law of sines, now using that 5.7 for angle C to find side C. So this could potentially form two different triangles. Okay, and in Thursday, I'll show you a visual of what this would look like. Okay, so this one could form two triangles. All right, let's do one more case here. So let's set this up. Sine of 29.5, sorry, we have side and an angle. These two match up. Over 12.9 equals sine of b over 8.7. When you cross multiply, you should get sine of b equals 0.33. Now, when you do sine inverse here, you are going to get 19.4 degrees. That's the quadrant 1 answer. If you find the quadrant 2 answer, you get 160.6 degrees. But that won't work because if you take the angle A that we already have plus that angle there, that's over 180 degrees. So that one won't work. So this is going to be the case where we just have one triangle. There's only one way to form this. So angle B is 19.4 degrees. Angle C, we can subtract A and B from 180 to get 131.1 degrees. And then let's do a law of sines to find that sides. Cross multiply and solve, and just make sure that you're able to solve these properly. You should get 19.7. Sometimes it will just ask you to tell how many triangles can be formed, so then you would say one triangle and stop. If it says to do that and then also solve it, that's when you need to do all of this. So always make sure you read the directions carefully. Okay, let's do one word problem related to this. So Marcy sees the top of a waterfall at an angle of elevation. So here's my waterfall. All right, here's Marcy. Let's assume that's straight up there. Okay, so here's Marcy, and she sees it at an angle of elevation of 26 degrees. She walks 120 feet closer. Let's make this part, just this part right here, 120 feet. Now her new angle of elevation, oh crap. All right, now her angle of elevation is 41 degrees. Okay, how tall is the waterfall? So we're looking for this value right here. So when you first look at this, you're like, I don't have enough information right here. But we can move some values around. So if you look, this is a straight line. So these two angles should add up to 180 degrees. So this would be 189 degrees. Okay? Then you have a triangle here. So we could subtract these both from 180 and find that just half outer portion of that angle, this part right here, is 15 degrees. So now we could use law of sines, because you can use law of sines when you don't necessarily have a right angle. So if I find this side, actually, let's call that y. Okay? So sine of 15, because look, I have an angle across from a side, so over 120, equals sine of 26 over y. Cross, multiply, and solve. So maybe pause, take a minute, and solve for that. You would get 203.2 feet. So now, if I know that this is 203.2, I have a side in my right triangle. So now I can use right triangle tree. So I could say sine of 41 equals opposite over hypotenuse, so equals x over that 203.2. And I could solve that just like we did before and find that the waterfall is 133.3 feet. Okay? So from here, follow the plan and the problems that you are supposed to complete. I will have office hours on Monday and then Thursday this week for any questions. And we'll have a quiz the second half of this week. Please, please, please reach out at any time if you have any questions. Hope you guys are well.